Hello, everyone. My name is Ethan with Dark Zebra. Today, we are doing a training on the National Vulnerability Database and the Common Vulnerability and Exploiter CVE programs. This is on Saturday, July 8th. Like all of our trainings, these are free. You can register at darkzebra.com, and you can get CEUs or learn about how to get CEUs on the darkzebra.com website. These will also be posted on YouTube for those who want to review or learn later on. So, what we're going to cover today with NVD and with CVEs. First, the CVE fundamentals, NVD fundamentals. We're going to spend some time on the CVSS scoring system, on how we determine the severity of a vulnerability. We're going to talk about some of the issues that had risen over the last couple of years within NVD, the organization, and how that's kind of been resolved. And part of that is how it's been resolved through this policy shift in 2026. And then finally, we are going to talk about how we can use AI to help us accelerate our investigations and our understanding of the vulnerabilities that are outlined in CVE. So, and then finally, we're going to wrap up. So let's get started. So what is the CVE? The CVE is common vulnerabilities and exposures. I'm sorry, I said exploits earlier. And exposures. This is a system for creating a catalog of known vulnerabilities on publicly disclosed vulnerabilities on basically software that might be used. It won't cover vulnerabilities that are within your private organization. It won't cover things that are not publicly exposed yet, because we don't know what it is. But it does track everything that has been publicly disclosed. It has four basic steps. There's obviously a discovery step by a researcher or even a vendor if they determine something, they find something internally, or a tool. So we have a discovery, we find a vulnerability, and we basically do some confirmation on it. We go to to a CVE numbering authority, called the CNA, and they will assign an ID within the scope. We'll talk about the scope in a minute. And finally, we are going to publish the record associated with that. So we basically have a vulnerability. We submit it to say, here's a vulnerability to the appropriate authority. It is assigned a CVE number, which is then published. And then downstream from that, your vulnerability management systems, your scanners, all of these components will use that data in their assessments. So, and one of those that is going to consume it is also the NVD, or the National Vulnerability Database. The CVE system was founded in 1999 by a minor organization. It is under currently the Department it's under CISA, which is a part of the Department of Homeland Security within the U.S. federal government. There are 500 or so CNAs, or CVE numbering authorities, and so far we are approaching 500,000 CVEs. Within the next couple of years, we'll probably hit it. One quick thing on the format: CVEs always have the same format. They will have a CVE and then a dash, the year that the vulnerability was, the record was created, and then a number, a unique number after that. That number used to be 4 characters long, But a little more than a decade ago, they determined that we were going to be having more than 10,000 vulnerabilities within a year. So that's now been expanded to just be a kind of almost like a raw count. You can almost determine the when a vulnerability was added to the system by its count, how high it is on that. So the National Vulnerability Database is run by NIST, and we're going to talk about the difference between, so we talked about a CVE, which is this standard database of vulnerabilities. And it's easy to mix these two things up, but what the NVD does is it takes CVEs and it enriches. It's an enrichment layer built on top of that CVE list. They don't assign the IDs. It only takes the records that have already been published and adds additional data around that to make it a little more machine actionable. So three primary pieces of data that it's going to add. One is a CVSS score. That is a 0 to 10 severity score. We will spend time on that in a little bit, from a vector string. And that basically helps us to determine, is this a low severity? Is it informational? Is it a high severity? Is it critical? We also talk about the common platform enumeration, standardized way for us to look at the product and the versions that will be affected by a vulnerability. This basically allows scanners to more easily determine if a version that you have installed is impacted. And then, of course, if you know what a CWE is, or a common weakness enumeration, this is a catalog of common weaknesses or types of weaknesses that are found in software or in systems. So it will have things like CWE 787 out of bounds right? CWE 79 is maybe cross-site scripting. So it's this catalog of the common types of vulnerabilities that are discovered. So it helps us to map this vulnerability that was discovered is this type of a vulnerability. So once again, these are two separate programs. CVEs are basically creating a database or an index of all of the discovered, publicly disclosed vulnerabilities. It is run by MITRE and is under CISA's sponsorship. One vulnerability gets one ID. And it lives at CVE.org, and it's funded by CISA, or the US government, through a contract. The NVD is an enrichment layer built on top of the CVE. It's run by NIST, which is part of the US government. The job here is to add the CVSS, the CPE, and the CWEs to publish the CVEs, additional enrichment, context, and understanding around a vulnerability. So it gives us, so the CVE will give us an ID, a description, and a reference, like references of notes or discussions on this disclosure pages. That does not mean it can't have additional detail. It often does, but the basics are the ID, the description, and the references. While the NVD, in its basic form, is adding severity scores to this, mapping it to which products and versions are affected, and assessing what type it is. The NVD lives at the nvd.nist.gov. So let's talk about the CNAs, the numbering authority, the CVE numbering authorities. Because there's a lot of CVEs that come out, there's not one organization that does all of the assigning of CVE IDs. For certain things like the vendor, a vendor like Microsoft will be responsible for, they're a registered CNA, they will issue CVE IDs for Microsoft products. Apple will do it for Apple products. There are coordinator CNAs. These are organizations like CISA, the CISA ADP, which will often fill in the cross-vendor gaps. Maybe there's a vulnerability that covers multiple vendors. Maybe there's a vulnerability that is affecting kind of a smaller piece of software that isn't a CNA and maybe doesn't fall under one of the vendor ones. And so it will try to fill in those gaps. And then, of course, there's also the open source, things like the Apache Software Foundation, which produces a lot of things like Apache software and open source Java versions. It does a whole lot of the open source ecosystem. And so Apache will be responsible for their own issuing their own CVE IDs for the systems, the open source systems within their domain. And part of this is that it's going to, you know, if you're going to Microsoft or you're going to Red Hat or you're going to Apple or you're going to Apache, you're going to get different types of assessments. And so a small open source library CVE might look completely different than an official Microsoft published CVE. Different organization, different processes. And so the amount of details and things can vary between them, but they all go into the same shared catalog. Now, the anatomy of a CVE record, and we'll talk about this a little bit more in a bit. So a CVE, as I said before, at its base, it is an ID and it is a description. And in fact, I'm going to go over to a CVE record right now. This is for the log4j vulnerability from a few years back, from 2021, so about 5 years ago now. This was the infamous log4shell vulnerability that kept many of us up through the middle of the holidays, which was not fun. Notice it was published in December of 2021. So right as everyone started to go to Christmas vacation, all heck broke loose. So this vulnerability was discovered. It was published in December. So we can see here that it was published in 2021. And so it wasn't necessarily when it was, this 2021 isn't necessarily when it was discovered, when it was published. We have a description here, and we have a list of information like here's the vendor, here's the product. There's a little information here, and then there's a whole lot of references. Now you'll notice here that we're missing, we do have some detail like the CVEs, but we're missing a lot of information about the severity and other pieces of information like that. So we have an ID, we have a title, we have a description, we have some references. In addition, when I look at this, I can see that one of the authorized, the CNAs here was CISA itself. In addition, if I look over here, you can see that that was the authorized data publisher. I apologize, not the CNA. You can see here that the CNA here is the Apache Software Foundation. So the log4j system is an open source logging system that falls under the Apache Software Foundation. And so they were the CNA in this case. And so I can look, there's credits here, references, some basic information, but we're missing a lot of information around like NVDs and stuff. I'm sorry, severity. So, anatomy of a CVE record, we just went through that. An ID, a name, a description, some references at a minimum. Often, we will see additional data that is added in through the NVD, such as what's called the CVSS vector. Once again, the CPE. So you'll see here, this is a vector we will discuss in a little bit. It helps us determine what the score is. In this case, this was given a CVSS score of 10. That is the highest you can get. It is a critical vulnerability. Anything that has a CVSS score between 9 and 10 is considered critical and needs to be patched ASAP. Depending on your organization's policy, that might be hours or days, but it is considered extremely dangerous. We're given the CWE here, and we are assigned who the CNA was for this organization. So it was Apache. Now, let's talk about the CVSS score. And actually, before we go to the CVSS score, I want to jump back to the NVD. So we've already seen the CVE, the basic CVE record, which I will jump back to again. This is at cve.org. Here's our basic CVE record. There isn't a lot of information about severity or anything like that. It is just the database of the record. But if I go to the NVD system and look at the same vulnerability for Log4Shell, the exact same CVE, I have that description that has come out of here, but I now have metrics. So I have CVSS scores, and I can see who assigned them. So the NIST created this CVSS score, and then the ADP CISA did the CVSS score here too. And they're both lined up that they're both critical. But it's not uncommon that you will see maybe the vendor themselves will add a CVSS, and that might be in disagreement with, say, what the NVD does. Another thing to note here is that we have multiple versions of the CVSS score. So version 2 is deprecated. I don't know if it's officially deprecated, but you will still see it on things from, let's say, 10, 15 years ago. You will still see that CVSS version 2 score. In fact, we even have it here. Generally, we're now mostly going by version 3. So depending when a vulnerability was published, it will use different CVSS versions. CVSS version 4 is the newest one, but this was released before that, and so there is no CVSS version 4 score. And version 3 is still the kind of the most commonly used one at this moment. I have those same references that were published in the CVE. The other thing about this is there is a, and I'm not sure if it's called KEV, just KEV, but it's a known exploited vulnerabilities catalog. That's an important thing to keep in mind, is that CISA tries to track if there are vulnerabilities, there are CVEs that are knowingly getting exploited in the wild. It will track those so we can identify, hey, we got thousands and thousands and thousands of vulnerabilities, but these subset are the ones we're actively getting reports of exploits. So, and then there's a required action here. Now, once again, notice that we have the CWEs. I believe these were published. In fact, notice here that the source NIST added in. So in the previous one, apologize for going back and forth on these records. Notice that the CNA, which was Apache, put in these 3 CWEs: improper input validation, uncontrolled resource consumption, deserialization of untrusted data. But when we go back to the NVD record, we can see a 4th CWE, improper neutralization of special elements using expression language statement, was added by NIST itself. So once again, even though the vendor did in this case provide CWEs, NIST, the NVD, still added a layer of enrichment on top of that. And it added in this known affected software, the CPEs, the common platform enumeration. So not only did it go and say, hey, Apache Log4j, this is the versions here, but it's showing, hey, on a Siemens system here, this affects that system. And you'll see there's a whole bunch of Siemens here, but NetApp, SonicWall, Fedora. So multiple vendors were affected by this. And the NVD essentially adds in the enrichment to say, hey, if you're running this version of Fedora, you're going to be impacted by this vulnerability. So back to our slides. I want to break down the common vulnerability, and I blanked with the CVSS issue, but I want to break down what a CVSS score is. And I have personally dealt with this, where I've had security researchers or pen testers or something, and they'll come and say, "Oh, here's a finding, it's a high." And I say, what's your evidence that it's a high? Like, well, I'm an expert. This is my feeling that it's a high. And that's not, we're not trying to go by expert judgment. We're trying to create a common way to take data that is perhaps not clearly defined and turn it into something that is measurable and explainable. And we highlight this in terms of two aspects. What is the exploitability of these metrics? And what is the impact specifically on the CIA triad? So I would assume that we know what the CIA triad is, but if we don't, the CIA triad in security means the confidentiality, can the data be exposed, the integrity, can the data be altered, or the availability, can the service be disrupted, or the data be blocked out, like in a case of a ransomware. The exploitability is going to ask, how can we attack this? How hard is it to attack? Do you require any privileges already? Is there any user interaction? You know, something like a phishing attack, or something where the user needs to click some button. And does the scope change? Can I move from one system into another system? Can I go from impacting just this one piece, this one system, or can I use this to gain a foothold and move into bigger systems? So essentially, when you get a report internally that says something's critical or high, make sure to ask, what's the CVSS on that? So you can fully understand how it's being calculated. And I'm going to go into the first. This is the an organization set up around incident response. They have a really good CVSS calculator. You can, NVD also has a CVSS calculator. It's pretty commonly, you can look at build out calculators fairly easy. This is how these are done is published, so it's not hard to figure out. But when we have a CVSS score, and this one, by the way, let's see if I have the address here. Notice that I have, if you can read this in my tiny text, I have the calculator, I have the version of the CVSS, and then I have this vector string, which maps to all of these pieces on the web page. So if I go back to this right here, which is the NVD database, you'll notice that they publish this CVSS vector string. And even though CISA and NVD are in agreement here, they may be in disagreement. And this allows you to say, hey, we're calculating this to be a critical, we're calculating this to be a high, and you can understand by looking at these, why did they change the score? What are they changing in their assumptions that affects the score? So in the case of Log4Shell, the attack vector was a network. I could send in HTTP headers. I could send in any kind of headers if they were getting consumed and sent backward into the logging system. That meant the attack vector was coming directly from the network, which is generally considered the most dangerous piece. If I had, you know, an adjacent network, perhaps I'm in a cloistered system, or something like that, where the network, you have to say, go from one system, one network into another network, maybe from a Bluetooth to an IP. That might be considered an adjacent network. And so notice that we go from, if I were in an adjacent network, I go from a 10 to a 9.6. Local would mean I need to be able to, it's a vulnerability that requires me to authenticate locally into the system. So it might be remote desktop, but I have to be on the system to be running it. And of course, physical, which means I have to have physical access to the machine or to the device. So we can see how each of these impact the score. In addition, we take into account things like attack complexity, right? The complexity of this was really easy. I could, I could go and look up very easily what kind of header I should put into my request. I could use curl to make a request, and I can immediately go all the way to a back-end logging system and have it potentially give me a shell. So it required very little understanding. But the complexity could be extremely high. If I have to have, and by the way, if you mouse over, you hover over these buttons, it gives you additional information here. So in this case, with log4shell, there was very little I had to do. All I had to do was have something that had accepted an a request over the network. But if there are several things that are, say, beyond my control, so I can't just necessarily accomplish it at will, I have to have maybe several steps to doing this, then the attack complexity becomes high. And notice that we automatically go from a 10 to a 9. There's things like privileges required. Do you need to have any access to the system already? Do you need to be an administrator? In this case, you didn't need anything. You just had no privileges required. And do I need a user to do something? In addition, and this is a key here, scope, change versus unchanged. For log4shell, what made it particularly dangerous is that you could use it to gain a shell account on the base system. And so the moment I'd gone from being within log4j or being within the logging system to gaining a shell access or a shell account down into the system, I had changed my scope. So that's why this was this one was marked as a change scope. Didn't impact the score very much at all. And then finally, so remember, these are basically our exploitability matrix, okay? And then I've got my confidentiality, integrity, and availability here. There's no impact on any of these. Doesn't matter how easy it is. It's just basically an informational finding. It has a CVSS score of 0. But if I gain access to the really highly confidential data, but I can't impact the integrity or availability of that data, right? Maybe I get access to a leaked database. Well, the confidentiality is high, and I still have a high score. But even though I'm not impacting integrity or availability. See where I'm at on my time now. Okay. So this is how we calculate CVSS scores. This is where you will get CVSS scores within the NVD, and why we will sometimes have contradictions, right? Where one researcher will say, well, that was high confidentiality or low, and maybe the vendor will say, no, that doesn't impact availability, and so scores may be different there. And so live calculator base score, we've been going through that. Attack vector of the complexity, privileges, the interaction, scope, and then the confidentiality, integrity, and availability. Perfect storm from here. Everything is as bad as it could be. You get a critical vulnerability. Now let's say in my environment, things are different. I have some compensating controls. So the NVD will publish vulnerabilities, but that doesn't mean that that's a very high level generic severity, CVSS, for everybody. It doesn't take into account all of the context around specific networks and environments. So in my case, let's say that I might have a vulnerable version of log4j, but I have very strict network segmentation. I have very strict egress rules, right? I've got a security group or something around this system that is consuming it, and the log, and I don't allow egress traffic. One of the key things is I'm going to make an inbound request. I'm going to trick the machine to essentially run a command and send that data back and allow me to open up a remote shell. But if I don't allow egress traffic, that changes the complexity of this attack. So this is my base score, but based upon my environment, I can go in using the CVSS calculator and I can define what is true for my environment. Generally, I don't pay a lot of attention to the temporal score. You can, but it's like, is there an exploit? In this case, there's an exploit, it's high. There's a remediation level, maybe it's not available yet. These things can impact it. But I'm going to go into my environment. This is where I'm going to give the effective CVSS score, what applies to my systems. So even though the NVD marked this as a 10, if I'm impacted, but it's on a system that has no confidentiality, availability, or very low confidentiality, availability, or integrity, we can see that that's going to lower my score. That's my requirement for those things. Over here, I can look at my modified attack vector. So by default, it's in a network. But if I am in, say, a cloistered network, where the traffic is not passed directly from that, so no one would be able to directly hit a server that would pass that forward, then maybe I'm on an adjacent network. We said before, I have an egress blocking network, firewall. So my modified attack complexity is going to go from being low to being high. We can see now that I've gone from a critical vulnerability to a high vulnerability. That doesn't mean that I don't have to patch it, but it gives me a better understanding of what my actual risk profile is. An important thing to take into account here, though, what we're trying to do is determine what is our actual risk as an organization, so we can focus on, we need to prioritize based upon actual risk. If I have Log4j on one system, and that system merely hosts a video of a bunny, right? Well, maybe there's no impact of a confidentiality. There's a low requirement for the integrity and a low requirement for the availability of this system, right? And notice that depending on that, my score goes down greatly. And if I go, and so once again, the integrity is not important, right? I can go from a critical to a medium based upon scope. The point of this is not to try and get your scope, to get your severity down. You're not trying to go in and say, what buttons do I need to click to make this a critical to a medium? You need to correctly assess your risk, the severity that correctly represents your organization. But you can use this to do that. So be honest and reflective on that to determine which of the CVEs do we need to address first. Okay, so I'm going to jump back to the NVD. We're going to talk about a couple of years ago, there's a little bit of a political clash with some budget cuts. NIST got a budget cut, and they were going to pause the enrichment, the NVD program. At the same exact time, as we're constantly seeing, every single year, there's more and more and more vulnerabilities. And so right as this was happening, over a 4 or 5 year period, there was a 260% rise in the number of reported CVEs. So that contract with the Department of Homeland Security nearly lapsed, but it got stabilized and it got moved into what's called a protected budget. So it moved from a discretionary budget into a protected budget. So this kind of helps to establish it long term. But this did bring up an overhaul that needed to happen within NIST. So as an example, between 2020 and 2025, we've had 263% growth in the number of submissions. I think that number is wrong. I think that should be, I think it's roughly, according to the CISA site, there was about 42,000. No, actually, I'm probably mixing up data here. So about 48,000 CVEs in 2025. And I think that NVD added enrichment to only about 42,000 of them. So there's a backlog that's forming. They can't get to all of these things. And that volume is continuing to go up. So even with the budget resolved, we're looking right now, the estimates on 2026 so versus 2025 are anywhere from 33% to 50% higher than it was last year. And so if we did almost 50,000 last year, we're looking at perhaps getting 70,000 CVEs this year. That kind of growth, and as we head into the AI era, we're going to see the number of CVEs that get discovered rising even faster. So it's going to become very difficult for them to maintain and to provide the enrichment data for all of the CVEs that are getting reported. And so they will now begin trying to triage this to be focused on what is truly the important pieces of this. So we talked about the KEV catalog, the known exploited vulnerabilities. So CISA's monitoring that. So things that are in KEV are the priority. They will get the enrichment data from NVD. Software that is used by the federal government, because CISA and everything is running off of the NIST, they're all sponsored by the federal government, that becomes the second priority. So the US federal government, software used by them will be the second, kind of the other category of priority here. And then finally, 3 is basically critical software, right? We know that Microsoft Windows is used by everyone in the world. That kind of becomes a well-known critical piece of software that's used everywhere. So it has a kind of a continued standard priority. Everything that can't be done will be marked as not scheduled. And I don't have an example of that right now, but I have seen them in the last couple of months where I start going into CVEs to look at details. And on the NVD side, it will say not scheduled. That means that the NVD, that NIST is not going to provide a CVSS score. They're not going to provide CPE mappings, and they're not going to provide the CWE classifications. That is, unless it is specifically requested. So an organization could request to get NVD enrichment done on a specific CVE. So there is a process to request that. But it's going to focus on these 3 categories and then as requested. So right now there's about 30,000 CVEs that are in the backlog that are not scheduled. The KEV ones are still prioritized, and so they get scheduled. And keep in mind, there doesn't mean that they're not. The ones that are not scheduled means right now there's no plan to even get it. And then the ones they're still scheduled, which means there's a little bit of time to get it sometimes. Right now, in some industry estimates, I'm trying to remember, I think Recorded Future and some others, I'm trying to remember where these numbers come from. I think Recorded Future estimated that about 20%, 15 to 20% of the reported CVEs are going to fall within these 3 categories. Now, that doesn't mean that the other ones, that they may still get to the other ones, but these 3 categories are prioritized. And so one more thing that's happening here is that what's happening is that the CVE numbering authority, the CNA, are now providing or should be providing CVSS scores where possible. So NIST is no longer, for a while there, the vendor could provide one and then NIST could do one. But NIST is no longer going to be doing independent secondary rescoring of CVSS scores. Essentially, whatever is going to be coming from the CNA is going to be accepted. There may be exceptions. I'm not aware of any. And so if you have something, I said there's request only paths. You can email NIST if there's something that needs to get enriched, but there's no published SLA on that right now. So practical guidance here. Understand that all of your data, all of your vulnerability data is essentially coming from a couple of sources. There is the published CVEs, and then there's this NVD database. There are a bunch of other places like GitHub, which we'll talk about. So the CNAs are providing CVSS scores now. That is estimated to be keeping us around 90% of the CVEs will have CVSS scores. But there's a high likelihood if you have a very niche system that isn't widely used and there's a reported vulnerability from it, that it may not, that vendor's not going to be a CNA. It's likely not going to be important enough to get an NVD. And so there's a very good chance that in some of these cases you won't have a CVSS score. But the CNAs hopefully are doing a good job of handling that. Excuse me. Okay. The KEV is going to look for active exploitation, and that's going to be a lot of that enrichment. It's going to add to the enrichment, and those are going to be the high priority CVEs. Vendor advisories are so don't just rely upon the CVE database. And depending on what you're using, different tools, they're probably already taking this into account. If you're using a vulnerability database system or a software composition analysis system, they're probably pulling from multiple sources already, and they're probably even giving their own scoring on this. So keep the KEV in place, the known exploited vulnerabilities. Vendor advisories are things we need to be monitoring. GitHub, so the open source, I can't remember the OSV, but there are GitHub and other places that are now publishing their own versions of known vulnerabilities. There is also the EPSS way of scoring. It's a little different than the CVSS. I haven't spent a lot of time on that, but it's another way of calculating severity. And understand that there are, if you go and buy something like Qualys, for instance, Qualys may produce their own QIDs, is what they call them. And so they will perhaps take and consume all of these sources of data and then publish their own vulnerability database. And that will become, and it might link to CVEs, but that might become the source. So when you purchase Qualys, it's scanning and it's using its own database. And so that, depending on your needs, it might be important to kind of buy commercial feeds of some of this data. So look at where your tooling is, your SIM, your SOAR, your scanners. What are they using as their source of their CVEs, of their vulnerabilities? Understand where that is. Don't assume that because a vulnerability doesn't have a score, a CVE, or that it's marked as not scheduled, means it's safe. It's very important that if you are affected by a CVE and you go and it doesn't have any of this enrichment data, you need to go and perform your own enrichment. You need to figure out where the CVSS score would be for you. Excuse me. Anchor on the KEV and the EPSS score helps you to prioritize the exploitation signal. So libraries and CVEs that are knowingly getting exploited should be some of the priorities you take in. And then also, as I said, add in the CVSS. And if, for instance, that you need to have this, there's a way to contact NIST if something needs to be enriched, especially if you are, finding it. If you perhaps are one of the people getting exploited by that, that's a good place to add to notify NIST and CISA. So to recap so far, CVEs are known publicly disclosed vulnerabilities. The NVD is a database of enrichment layer on top of the CVEs that adds in things like CVSS scoring, common platform enumeration, and CWEs to help us better understand the severity of the situation. As we move forward, as NVD cannot handle all of the requests for enrichment, it will perhaps become important for us to rely upon our vendors, rely upon the commercial sources as well. But there's with the day and age of AI here, we can easily start doing our own assessment and triaging. And I'm not even, by the way, I'm not saying that you should do your own assessment. I want to give an example here of where you are a security engineer. You get contacted about a possible vulnerability, a CVE. Perhaps it's brand new. And if you're like me, you have had many times where you've spent several hours trying to go through forums or Reddit or notes from the vendor, assuming it isn't behind some paywall, to determine how is this impacted? What versions are impacted? What are my indicators of attack or indicators of compromise or whatever other kind of information that's there? AI has allowed me to help speed up that process very quickly. And I want to walk through that as an example here. So I'm going to grab a couple of pieces of data here. I have here an example AI prompt. It's going to say basically you're an expert product security engineer. You've just been notified of a new CVE that may be impacting your environment. That's the log for shell. So basically, we're doing a standard role, context, and role, context, and action here. So there's my role, my context. I'm going to say review the links provided to determine what is the CVSS score, severity. I'm going to have to copy those. What conditions are required for the vulnerability to be exploited, and what mitigating steps can be taken. And then I'm having my action, which is provide a succinct overview in Markdown that gives a 1-paragraph overview of each article. List of the conditions that are known so far and any open questions. How can we identify if we are impacted? What steps can be taken to mitigate? And the source URL behind each claim so it can be independently validated. Right, that's an important piece. I'm telling you, we can use AI to help us be faster in our research, but we also need to make sure that we are still getting the accurate data. So my expected output here is going to be, and I have not tested this, so let's hope it goes well. Oh, I can't copy that. Give me 1 second. While I pull up the actual slide. Okay, I'm going to copy this text. I'm going to paste it into my Claude chat. And I am going to actually go back to the, not the CVSS, go back to the NVD here. And I'm going to grab, just like Packet Storm, they had some good basic stuff on it. So I'm going to grab this URL right here. Actually, I'll grab, and I'm going to paste it. Messed up my formatting here. So I'm going to provide this here. And I'm going to now run this action. It will take us just a second. While that is going, I'm going to jump back to my slideshow. What we are expecting to find here is a paragraph per source reviewed. So it should go in and look at that packet storm file and say, this is what this is saying. It should help. And the more vulnerabilities that are happening, often I have found that I will have an NVD record, and there's a whole lot of references, but I can also go and Google something or some other search engine and find some articles written by security researchers that provide additional details. Really, what we're trying to find out is the known conditions for exploitation. The presence of a vulnerable library does not mean that a vulnerability actually exists. So we need to know, are we in a vulnerable version? And we need to know what other conditions are going to exist for this to be exploitable. Plus, if there's any unknowns that are there, and then we're going to look at whether our environment's impacted in concrete mitigation steps. So here's my output. Security review, article. Oh, it says it couldn't fetch it. It's the same public expert write-up mirrored by the exploit DB and other trackers. It's cited as the primary reference for the official NVD. So Claude can't grab this one directly. Sometimes you can just go to the article, copy and paste and put it in. But it's basically saying packages of working proof of concept demonstrating unauthenticated remote code execution via a crafted string, vulnerable to the application. Here's our CVSS score, 10. Here's our vector, CVSS2 score, the CVEs, and then a status and kev. It basically tells us this is a maximum score. And then this is the important part, conditions required for exploitation. The application has to use log4j core. It has to be in these versions. And the attacker must be able to control log messages or log message parameters that get fed to log4j. So if I'm taking HTTP request headers, passing them directly to my logging system, that's a place where I can feed this directly back into that system. The attacker needs outbound network reachability. We discussed egress traffic blocking. And then it talked about the versions of the Java as well. Known open questions, how to identify if you've been impacted. So it's saying, hey, look for the log4j scar, log4j core jar files. If it's not clear, if it's just a generic log4j, look inside to see if you can determine which version is there. Even if you can't determine it clear, just be aware if you've got it, be mindful of what's happening there. It talks about canary tokens. So basically trying to make outbound calls, look for, see if you can find any crafted calls in your network traffic, look at your review, look at your logs to see if that's happening, blah, 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 blah. So not too exciting. Well, exciting, not exciting. Stressful when you're in the moment, stressful when you're trying to figure this out, but this is very powerful and very useful. Like I said, you could spend hours reading articles and going through forums trying to determine it and building your own thing to do your investigation. Now AI allows us to quickly be able to investigate and move further on that. Excuse me. And I'm going to grab my next post here. So we had discussed that. There we go. That based upon my network configuration, things may be different in your environment than it is in the generic CVSS score that's reported. And so AI can also help you do some of these CVSS scores to look at what your actual effective CVSS score is. Excuse me. And so here's an example prompt where I say, given the log4shell and the basic CVSS determined above, reassess it based upon the following environmental controls. All egress traffic is blocked. The logging system is in a network segmented from database systems. So we're basically saying I have no outbound traffic, and this is isolated and segmented from other things. Provide the resulting CVSS 3.1 vector string and severity rating and a 1-paragraph justification. So I'm going to go back in here. I'm going to paste my prompt into Claude. And I'm going to wait just a minute here as it does its calculation and it uses up its tokens. And it will take into account the information I've given it. And it will hopefully calculate what my actual risk is in this environment. Doesn't mean it's going to be perfect. Sometimes you're going to have to give it additional context. Sometimes it will. So you've got to keep your brain engaged. You've got to keep thinking about this. So it's not bad sometimes to have, and that's why I'm having it generate out a CVSS vector, is I want to see how does it change the score based on the CVSS. So I can go and look at its assumptions and determine if it's a good way of assuming or not. So it will give me the vector string, give me the resulting severity, and a 1-paragraph justification. So we have already kind of did this earlier on the CVSS calculator site, but this is just a very good way to basically improve how I'm working on this. I'm going to click on the quick answer for right now. Okay. So it still has it, the base vector as a 10.0, but it says based upon the environment, I'm now at a 5.4 median. Why is that? So it says egress traffic is fully blocked. That changes my modified attack complexity to low, my modified confidentiality, integrity, and availability are reduced because it can't exfiltrate or impact that system. Now you can debate. You might go and say, well, I can see the modified confidentiality, but they might still be able to run commands in the local system, so they could still impact integrity and availability. So I might question that, and I'm not going to type it now for the sake of time, but it says Log4j's exploit chain requires a vulnerable host to reach an attacker-controlled endpoint and to retrieve and execute malicious payloads. Then it says logging system integrity. Because we are segmented from database systems, our modified scope becomes unchanged. Once again, might want to question that because it's still changed in terms of the affected system. But this can help you in assessing what your actual severity is as you move into the, as you do your investigations in the future. Always take it with a grain of salt from the AI. It can be too aggressive sometimes. I'm going to go to the CVSS score here. And you'll notice one thing I love about this is I can go up to my browser bar and I can paste my CVSS score directly, my vector, directly into the bar and hit enter. And it will adjust my score here. And it looks like it did not match up with what Claude said, unless my eyes are bad. No, Claude said 5.4. Here it says 6.4. But notice here that I might have had some things already set up that are affecting that. In fact, I had nothing. Oh, those all not defined. So I might have impacted this. But notice that it's put the modified attack complexity, modified attack complexity should have been low. Anyway, so my path here, sometimes I'm just going to brand new window. There we go. So now it's at 5.6. So it's to define the modified attack complexity, privileges, all of that stuff. Now you can go in and do some further tweaking here. Say, I disagree. I'm going to say that the modified scope isn't changed. And I'm going to say that maybe integrity and availability are still impacted. So it might still be a high, just not a critical. Well, I hope this was useful training today. So if you're like in a Security Plus and you're doing your CEUs, we have that documented and what this falls under. Remember that you can register for future trainings at darkzebra.com. And there you can figure out how it's a great way to get CEUs if you're trying to keep yourself current on your certification. You know, we have frequent lessons like this, frequent presentations. You can register, receive CEUs, and keep your certifications up to date. With that said, we don't have any questions today, so I will go ahead and end the sharing. Have a great weekend.